Hello everyone and welcome back to the fourth session of the Python Intermediate Bootcamp. So you are watching this session, which is a re-recording of the session that we held some weeks ago. And this is because we had some issues with recording the live content and it ended up being unusable for networking issues. The quality was too low. So you're seeing a reshooting from that reshooting from that content. I'm going to try my best and um, stay true to what was delivered that day, and we will cover the same things that we covered. So you're going to see the actual same content, but we apologize in advance for any misalignment that you may see during this session and the previous one that was held live. So I think with this out of the way, let's dive into the code because that's what we are here for. And okay, so we would like today to build an auction system because we now right now have a digital marketplace that is an application that is able to handle assets for us and sell them autonomously. But we would like to take the opportunity to have bids on these assets that we're selling. So just to give an example, if we're selling an asset for 2 algos and someone else wants to buy that for, they are willing to buy that for only 1.8 algos, right now there is no possibility for them to place a bid, and they would essentially have to wait online or have some kind of alerting system that waits for the price to change if the price is going to change, if the owner of that listing is going to change the price. So yeah, we just want to be able to accept bids so that also like the owner of the listing can see for themselves what is the best bid for that asset at the moment, and they may decide to accept that bid. So before we write any code, um, I'll spend just a couple of words on design an auction. And there are multiple things that you could do to design an auction. What we are going to do is memorize the best bid in alongside the listing itself. So we're going to make a slightly bigger box to hold the information about the best bid, and we're going to allow any user to place a bid, and we're going to allow any user to outbid the current best bid, and we're going to allow the owner of the listing to accept that bid. Another alternative could be that we allow any user to place bids, but those bids are not memorized alongside the listing. They are memorized in a box owned by the bidder. So advantages and disadvantages of both. Our approach is easier to code and it's easier to verify that it is correct because we don't have to, take multiple bids into consideration. We just have the highest. However, a disadvantage is that this can create race conditions. What I mean by that is that if an owner, if for a listing I have a bidder A, and I am bidder B, and I try to outbid A, well, A must be refunded. So what this means is that I will add a reference to the bidder A in my own transaction. However, there is always some inherent latency in any distributed system, so it may take some time for me to compile, sign, send, and wait for approval of this transaction. So in the meantime, someone else may already have outbidded A. So A was the previous bidder, I am B. Let's say that C outbidded A before me. And by the time that my transaction reaches the application, I'm not going to find A as the previous bidder. So we have to be aware of this race condition in this system. On the other hand, the other system is more complicated, but it doesn't suffer from this race condition, because if anybody only interacts with their own box and they don't outbid the same highest bid, then there is no possibility of race conditions. So, these are design choices that you may want to do differently in your own application. But for the sake of example, let's stick with the first hypothesis that we are going to only memorize the highest bid. Okay, so now it's time to write some code. And so what we want to do actually, the very first thing, so we said that we want to keep the bid alongside the listing. So I want to memorize the current bidder, the current bidder, best bidder, and I want to memorize how much they bid for, so the bid amount, and I want to memorize what price they are willing to pay for this bid. And with these two information, we're going to compute based on the amount of the asset that they are bidding for and the price that they are willing to pay. We're going to figure out the amount of algos that they need to pay. Let's see how this changes the math and the box size. So the key doesn't change. However, the value in the box is now 32 bytes plus 8 bytes plus 8 bytes, right? So this is now, using my calculator, it is 64 bytes for a total of 112. So our box, well, to be exact, the key plus the value of the box is 112 bytes long. So for reason that we will encounter later, let's split this information and say that we have a 4-cell box length that's equal to 48, because that's 32 plus 8 plus 8. Yeah, exactly. And then we have a key length, but for the value, not for the key. Okay. And this is 64. So we have a 4-cell box size, which is equal to the sum of the previous two. How do we compute the MBR for a box? It's the flat MBR times 400 plus 400 times the box size. For cell box size. Okay, so we want to change. So the first thing that I want to change is this method, because in this method we are creating the box for the first time, right? Because we are using the opcode box put. So if we recall, what this opcode does is, I'm pressing Control and then clicking on the opcode, which should bring me to some docstring with some documentation. So creates A if A does not exist. Okay, so, and we already checked that it does not exist. Right, so this is the bit that we want to change. And yeah, let's comment this just for the moment. And what we want to say is that, oh, we want to create the box first, the same key, and the value length, because the length of the box is the value for it. And so what create returns is a Boolean. And this Boolean is true if the box was created. So if the box already existed, this opcode is not going to do anything, and it's going to return 0. Hold on, maybe that's not true. Hold on. Create a box, failed if the name A is empty or B exceeds. Okay. Box create will fail if the referenced box exists with a different size. So, okay, there are all kinds of side effects, but in our case, we checked that it does not exist. So create should only fail if this key is empty or if this value exceeds the maximum. But in our case, this is not true for us. So, okay, we created the box, and we actually want to be sure, we want to assert that it is created. And then, just like we did in the deposit method, we want to, so the create method will also fill this way with 0 bytes. So the content is all zeros at the moment. And we were storing an amount and a unitary price. So we essentially, well, I guess that we can just change this line. Replace the box key, start at 0, and we write this information. So the first 16 bytes. Cool. So far, we should check that all of our reads and writes are still correct. And my intuition tells me that they are, because it's only for the first 16 bytes of the box. We are only appending information. So as long as we use the indexes for this box starting point, we should be fine. So for example, a replace, we start correctly at 8. Anything that's we start at 0, that's correct. In this case, we delete the box. Okay, we're going to see later how this will have to change. And buying changes the box, but it changes, okay, so it changes the current deposit. Perfect. Okay, so this code should already be fine. And now I'm going to pause for just a second. Okay, here we are. Yeah, I was just checking something on my notes. We want to write the bid method at this moment. And let's do it after the buy method. So the bidder will in general be different than the owner. So we want to uh, get this information that can identify a box. Okay, so we want to accept a bid pay. Quantity and unitary price. This is the unitary price for the bid. Okay. I want to run my linter. Okay, awesome. So to just give some reference to what this is, these are the identifiers of the listing box. This is the payment. Oh, we didn't talk about this yet. So in the buy method, right? We take a buy payment, but this payment doesn't go to the contract. It goes directly from the buyer to the seller because there's really no reason to hold these funds on the contract. It's just better to release the asset and pay the seller directly. We have no use for this on the contract. The only thing, because then we will have to write some other method that unlocks the profit of a sale, but I don't really see a reason to hold these algos in the contract because for in the case of a buy, right? The seller is getting algos and any address can receive algos. It would be a different case if the seller is getting paid in some kind of asset. So they are trading an asset for an asset. And then I would want to only release the assets. What I mean is that the seller would have to be already opted into this asset in order to receive it from the buyer, right? And this may not be the case at the moment of the sale. So in that specific case, I may decide that the contract is going to be the custodian for the profits of the sale. This is not the case in this contract because the seller is getting paid in algos and any account can receive algos. Uh, for the bid, we actually want to be the custodian. The contract wants to be the custodian for the algos. The reason is that the bid is not an exchange, right? The exchange may happen at a later time. It may not happen at all. So we cannot rely on the fact that the funds are going to be in the user account in the bidder account, right? Because they may place a bid and then I don't know move the funds, and even then it will be difficult to extract the funds from the bidder account, right? It would have to be the bidder that signs a transaction that sends the algos. So just in general, it's very cumbersome, right? So in this case, since it's not an atomic trade, an atomic exchange, we want to hold the algos in the contract itself. So this is what the payment transaction is for. Because at some point, if the owner accepts a bid, we want to exchange the assets for the algos, and the algos need to be available. The quantity is what the quantity of asset that the bidder is willing to buy, and the unitary price is not the price of the listing, is the price that the bidder is willing to pay for this quantity of asset. Okay, so let's start by checking something that is not strictly needed for the execution of the bid method, but is going to be useful in the future. So we want to check that the sender is opted in the asset. Now, this is only useful when, in this case, the sender is the bidder, right? So this is only useful when the trade is actually executed, if the bid is accepted, because we wouldn't be able to accept a bid if the buyer somehow didn't opt in the asset. So let's say that in order to place a bid, you have to be opted in that asset. Now, of course, the bidder is free to opt out of that asset after placing a bid, and there will be no way to prevent that. However, this would be a nice sanity check that is not needed for the bid method, but it's needed for the whole flow of the application in order to make accepting a bid much more likely, right? It would have to be a malicious attack and not something that you do um, by mistake, opting out of the asset. So this condition, we don't need it right now, but it's nice to have, and it will prevent problems later down the road. Okay, we want to identify the box for the listing. Okay. And okay, so now we want to differentiate if we already have a best bid available in the listing. So we're going to say that the current bidder is an account. We have to import that. I'm going to import this from AlgoPy. Linting is going to take care of the order of the imports. And this account should be the box extract. The box key, and we want to start at 16 and it's 32 bytes long, right? Because it's an address. It's the address for an account. We start at 16 because the first two are two 8-byte numbers, the unitary price and the amount deposited. And so let's recall that if a box is created, the first value of the bidder will be essentially all zeros. It will be filled with 0 bytes. So we can check this, because if the current bidder is different than a constant called the zero address, the zero address is exactly what it sounds like. It's an address filled with all zeros. It's not actually a valid address, but it serves as a null address, let's say. So it serves as not an undefined, but a null address. And okay, so what needs to happen if we already have a bid? So if the current bidder is set to something and it's not null, we want to refund the previous bidder. Well, actually, we need to first check if this new bid is better than the previous one. So let's extract some additional information from the box. So the current bid quantity, this is equal to a number. It's extracted from the box with the box key 48 and 8. This is 16 plus 32. So right after the address, we have the bid quantity, and right after the bid quantity, we have the bid price. Right. Okay, so now we want to assert that the unitary price, so the new price for the price for the new bid is strictly higher than the current bid unitary price. And note that we do not check if the quantity is lower or higher. For us, a better bid is just a bid that pays more, even if it buys less of that asset. You may obviously choose to do something different here. And now we want to figure out how much this bid pay should be, because like if we are overwriting the bid, we want to calculate how much algos the new bidder should pay. And to do this, we are going to do something else before that. So let's make this as a to-do. And we have a function here, right? We have this function. Yes, this function right here, which is, if we recall, this function is the function that takes a quantity in assets and a quantity of asset and a price for that asset in algos and figures out the how much algos that corresponds to. So we want to essentially refactor this into a function because we're going to use this over and over. So let's do something here and call this a quantity price. And we will know that this is like the code that computes this quantity. And then we want to return the amount to be paid. Okay, so at the moment, we should set this as a subroutine, which we can import from Algorand Python. And what a subroutine is not an externally exposed method. It's like a unit of code that can be called in methods or from other subroutines. And it's essentially a function. It's like think of it as a contract function, right? And this is just a way to refactor code into a function and call it from other places and not having to repeat yourself. So we want to make this general because right now we want to know the asset decimals, the quantity, and the price. So I think let's import them as just numbers because they could be coming from different sources. So we want to have a quantity as a native integer, not an ARC4 integer. Price is going to be the same thing, and asset decimals is going to be the same thing, native integer. And this would be the price, the quantity, and the asset decimals. And we return the result. Okay. Now with this refactor, we want to take note that this is called quantity price. And we are taking a quantity, a price, and an asset decimals. So we want to go back to the two places, yes, this, and do amount to be paid. This is equal to self quantity price. This takes a quantity. A price and the asset decimals. Okay, I'm going to check that. This is what I have in my notes. Yes, perfect. So we go back to the bid method and we have to do the same. So the current bid amount, this is going to be the quantity price. So the quantity is the current, nope, hold on. Oh, yeah, exactly. We are trying to figure out the refund for the previous bidder. So it's the current bid quantity and the current bid price and the asset decimals. Let's run our utility. We'll worry about this later. Hold on. Missing return type annotation for public function. So this returns a number. Okay, we still have this error because we didn't write the rest of the contract yet. Okay. So we now need to refund the previous bidder. Receiver will be the current bidder, amount, the current bid amount, and fee equal to 0. Okay, so this is the point where I was saying that this design could cause race conditions. What I mean by that is that we are refunding in the same, like by placing a new bid, we also need to have a reference to the previous bidder. This is the point where we have to have a reference because we are sending a payment to the previous bidder. So this is the point where this comes into contact with us. Okay, so we have now refunded the previous bidder, so we should be now be safe to write the new bid. So we're trying to figure out how much the new bidder should pay. So we use the quantity, which is the new quantity. Or maybe this is quantity.native, probably. Yeah, because it's wrapped in a ARC4 integer, and then the unitary price and the asset decimals. Very well. So we want to assert that the bid pay sender is equal to the transaction sender. So the payment comes from the same bidder, comes from the same address as the new bidder. And we assert that the bid pay receiver, in this case is the contract. The amount is what we computed. If all of these things hold true, this is a valid new bid to be written into the listing. So we conclude this method by replacing the content of the listing starting at byte 16. So we're not overwriting the owner information, we're overwriting the bidder information. And we want to save the address of the new bidder, the new quantity. Oh, I was almost making a mistake here. We want to concatenate this information and the unitary price. Okay, perfect. Very nice indeed. Okay, let's go forward and write the last method, the last new method that we need. The accept bid. Now the accept bid obviously can be called only on the boxes, on the listings owned by the caller. So we don't need to specify an owner because it's going to be the sender of this call, or we need an asset, and we need a nonce. So we only have one bid per box. Maybe I need to do this for this method too. Yeah. Okay. And we're only going to have the best bid in each listing box. So box key. We did this a lot of times by now. I'm going to just write it. Now, obviously, if you want to accept a bid, there should be a bid written to the contract. So we check again against the zero address. And we are sure that if an address is present, also all the other information are present because we write everything at the same time. Very well. So we know that the bidder already deposited the algos for this bid onto the contract. So let me check my notes and I'll resume the recording. Okay, so as I was saying, we are trying to figure out the information on on this bid. And so right. Okay, so we want to extract some information from this box. And I'm going to first write it down and then we'll talk about it. Best bid quantity and best bid unitary price. This is from 6 to 8. And then with the current deposited, it's from 0 and it's 8 bytes long. Okay, so a couple of words about this. So obviously usually, let me say that, usually the bid will be for a price. Well, actually, hold on, I don't think that we checked. Yeah, so we have no check on the bid price, right? We know that the new bid must be better than the current best bid. However, the bid price could be potentially higher than the listing price, right? This doesn't make too much sense because, of course, if an asset is available to be bought at some price, it doesn't make sense to bid at a higher price, right? But however, so we allow new bids to be higher than the listing price. We don't care about it as a contract developer. If the bidder wants to do that, they can. And it's responsibility of the bidder to place a reasonable bid, so for a lower price, and it's responsibility of the seller, the owner of the listing, to only accept bids that make sense for that listing. So we allow bid prices to be higher than the listing price. But even if we didn't, so even if we had a check that says, okay, bids must be lower than the listing price, well, this does not prevent the owner from changing the price later on. So let's say that an owner puts a listing price of 2 algos per unit and someone bids at 1.9 and then the owner changes the price and puts the price at 1.8. There's nothing that can be done in that case, right? So you can always end up with a higher bid price than the listing price. This can happen even if we check at the time of the bid. So all of this is to say that not only the price, when we accept a bid, it's the responsibility of the owner to only accept bids that are good for them, right? And in the same spirit, we will have to be careful about the current deposited and what the bidder is willing to pay, is willing to buy. Because at this point, I don't think that we even check that the bid. Yeah, I don't think we do. I don't think that we check that the bid quantity is lower than the current deposited. But it's the same principle. In principle, it is the same thing as the price. Like even if we check, someone else could buy a portion of that listing and lower the deposited amount such that the bid quantity is higher than the available listing quantity, right? So I don't think that there's any point in checking those at bid time. However, when we accept a bid and we subtract assets from the contract and we send them to the bidder, now we need to check that we take the maximum between the bid quantity and the current deposited, because otherwise we may send more assets than the listing owns. And this is a problem because all the assets for all the listings are held by the same contract. So this will be a pretty big vulnerability. So let's do that. Let's figure out the minimum, the mean quantity. So the minimum between the bid quantity and the current deposited, because that's as far as we can send. It's the current deposited if current deposited is less than, if I can get it right, is less than the best bid quantity, else is the best bid quantity. Okay. So based on this, right, we want to figure out. So we know that the bidder deposited into the contract algos that can cover all of this quantity. But in general, the minimum quantity could be less than that, right? So we need to figure out the best bid amount, which is the amount of algos that can cover the mean quantity at the best bid unitary price. So this is the self quantity. We need to calculate the amount of algos, and this is the mean quantity, and the best bid unitary price, and the asset decimals. Okay. And now we are going to send. This reminds me that I forgot to do something. You have to submit the inner transaction. The receiver of the payment will be the sender, which in this case is the owner of the listing. The amount will be the best bid amount. The fee will be equal to 0. Submit. And then we also want to send the assets asset receiver. We want to send the assets to the bidder. Asset amount will be the mean quantity, p equal to 0. Submit. Okay. So we exchanged the algos for the assets. Now, in order to keep a clean and correct accounting, we need to update not only the deposited quantity, the current deposited, because we obviously sold, but we also want to update the best bid. This is only 2 lines. Box key. And the current deposit is going to be the deposit before the trade and the amount traded, so the main quantity. And we want to update the accounting on the bid. Main quantity. Okay, so this should do. Yeah. There is something that we didn't check. Let's say that the current deposited is 0, or the best bid quantity is 0 for whatever reason. It may happen right now because we don't delete this information. We don't check. Well, then if either of these is 0, the mean quantity will be 0. And this means that this transaction will essentially do nothing, right? Because if the quantity is 0, the multiplication is 0, so the payment is 0, and the let's see. So best bid quantity current deposited. So yeah, if current deposited is 0, then what happens? Hold on, is this a bug? Let me think about it for a second. I'll stop the recording. Yeah, no, of course, this is not a bug. So I was confusing myself, but if this is 0, the mean quantity is 0, the amount will be 0, so they exchange, these are empty, these become empty exchange, an empty trade, because this best bid amount is 0 by definition, and the mean amount is 0 by definition. So, I mean, technically you can keep calling this method with either amounts equal to 0. It will do exactly nothing. It will subtract 0. So this is maybe a check that you may want to do in your production application, but for now this is not a problem. Very well. There's something else I wanted to say about this. Yeah, of course. So currently there's no way for the bidder to be refunded unless someone outbids them, right? Because if they get refunded if someone outbids them. However, at the very least, I think that the bidder should be refunded when the owner of a listing withdraws everything and deletes the box. Because think about it, if they delete the box, we lose the information about the best bid, the current best bid. So we lose any information in the contract that can allow us to approve a refund to the bidder. So we want to change this withdraw method, and we want to add some code that says we're going to extract the current bidder, and this is an account. Box key starting as 16, 32 bytes long. And if we have a bid, so if this is different than the zero address, then this is equal to quantity price of, let's extract the information in this line right here. So we save some lines of code. I think this is clear by now what we're doing. So this is the saved, the quantity, and this is the price for the bid, the quantity for the bid, obviously. And we are just extracting it directly and passing it to the function instead of placing it in a intermediate variable. Is the asset decimals, and we have figured out how much the bidder deposited into this contract. So we send a payment. Nice. And then we still delete the box. We send the payment. Oh yeah, we give the owner the funds for the box, and we return the assets. No, yeah, we return the assets because the profits go directly to the buyer, to the seller. Okay, last minute check. Let's see if I have forgotten to do something. This looks fine. We just changed this. Allow asset, this shouldn't change at all. This we wrote right now. Withdrawal is changed by. Okay. So I don't think that buy should change actually, right? Because it's fine. It's just based on the, yeah. Yeah, if we recall, we rely on this subtraction to give us an error if the quantity is higher than the current deposited, because otherwise this will underflow and cause an error. So we don't need to check the current deposited, but I mean, this code shouldn't change, right? Because this is the situation where someone buys and the bid amount doesn't change, but the deposit amount changes. So, I mean, this is the situation where you could end up with a lower deposit than the bid, right? But I think this is fine. Right. Okay. I think this concludes writing the contracts for it. We are not going to write tests. However, the previous tests should still pass, right? Because nothing should change about the buying behavior other than some minor things. Let's try that together. Some minor things like fees that we have to provide for the methods, because now we in some places we do more inner transactions, so we may need to fund. We changed the box MBR, so ha, ha, ha. This is in the withdraw method. All right. Well, yeah. This is bytes because it's from a box. We need to convert this to an integer. Perfect. Uh, just because I can anticipate this, let's go into the testing and we need to update this. Let's just, um, let me check my notes actually. Uh, yeah, so let's take this code and replace it here in the testing. And we want to, yeah, so this is for sale box MBR. Okay, let's just run the code, run the tests and see if they pass. I may already have changed some of the tests. Um, yeah. I may have already changed some of the tests to have them pass. But let me just open up something in my notes and see what exactly changes. Yeah, so we have increased the number of inner transactions that we do in the withdrawal. Well, not always, right? Because this is behind an if. So if you have no bid, then however, we are always providing this fee to the contract call, just because it gets tricky to detect if there is a bid currently written into the contract. So we just send 4,000. Of course, if you may want to try and save one fee for the inner transaction by checking the content of the box and seeing if there is a bid present at the moment. But anyway, we are getting a little less back because we're getting the box MBR minus the fees to get it. And very few things should change in the tests, actually. Again, maybe we have to increase the fees in some places where we have more inner transactions. So for example, in bid. And we're not going to write tests for bid and accept bid. These are things that we're going to see in the front end. So we're going to check manually that they work. But if you want to write tests, that can be your homework. They are very much in the same spirit as the other tests. So I think let's jump to the front end and integrate this new functionality into our UI. All right, so welcome to the second part of this session. And we are going to change the front end and we're going to hook it up to our new application with the auction functionality. And for that, like in order to exemplify how to add this functionality, we're going to do a couple of things. I'm going to announce them all right now, and then we're going to implement them one by one. But we're only going to see the final result all at the same time. So since now we are tracking more than one kind of information, because we were tracking only the listings in this iteration of the front end, and we're going to have to track um, the best bid for any listing. So we are going to have to write another function, And we're also going to use like the seller, the asset ID, and the nonce is always 0, but we're going to use these two fields essentially to determine the listing that we're interacting with. We will need to use this because now we cannot just fetch all the listings, but we will need to fetch the bid for the specific listing that is selected in the UI. So we will use these form fields to select the listing for which we want to read the bid. Then we will need, well, at least, well, no, exactly two buttons, two method calls components. One is for placing a bid and the other is for accepting a bid. So yeah, a new function, a new label that displays the query, the best bid, and two methods, one to place a bid and one to accept a bid. So without further ado, we want to write this function. And we mentioned that we were going to use information from these two fields. So right after them, we're going to write the best bid query, which is a use query. Yeah. With a query key of, well, let's define for sure the bid, right? And other identifying characteristics of this are the seller address, the oh, sorry, the app ID, the seller address, and the buying asset ID. Because like this is just a fixed key, but if any of these changes, then the function should be rerun again. So all of these keys are used also to make this query react to changes. And the query function is very similar to what we already wrote. It's an async function. And we're going to extract the box content. So algo and client algo d, and then get application box by name. So at this point, we already know the name, right? Because we can compose it from the seller address, the buying asset, and the nonce. If we recall, this function takes an application ID and a byte array. So we want to have the seller address. Hold on, let me do something. I want to step into the front-end project. And I want two consoles open for the front-end project because one, we are going to use to instantiate the development web server, and the other one we're going to use for fix. Is it just run fix? No, it's lint fix. Perfect. Okay. So this is the code address, public key, and then also the encode. This is a number, so encode uint buying asset ID. And the encoding of 0, because this is the nonce, which is always going to be 0. Okay. Ah, yeah. Never forget the do. Very well. So from the content of this box, we simply want to return an object that contains the information about the bidder. Now, in the box opcodes, in the contract side, we are used to operations that take the starting index and a length. And this, in this case, we just have the start index and the end index. This is why we have a slightly different representation, but you can check that for yourself that this is the same. This is an encode. Oh, sorry, it's a decode number, box content, value slice, and this is from 48 of 56. Then we have a bid unitary price from 56 to 64. Ah, I forgot a parameter, begint. We want the decode to happen in a begint mode modality. Okay, that looks good to me. Yeah, duplicated code. For the moment, this is fine. Unused function. Well, we're going to use it right now, actually. So let's scroll down to the almost the bottom of the interface because we want to add something right after the buy form. And we want to have a divider, first of all. And then we want to have a div. With a label. Let's take the label from here. That says best bid. Okay. Now we want to conditionally render the result of this function that we just wrote. So let's say that if the best bid query is not an error and the best bid query has some data. Now, the reason why I'm checking both of these conditions is that this is the data may be stale data from a previous query that did not go into an error. I don't think that the data is necessarily refreshed or checked. So this is just both conditions check the things that we want to check, that the last is not an error and it has some valid data inside it. And we want to return a div. Hmm. Okay. Inside this div, we're going to do something very similar to what we did here. Here we are displaying a listing. We're going to interpolate a string and display a bid. So I would say quantity of the bid. This is the best bid query, data, bid quantity. Okay, price. This is best BigQuery unitary data unitary price. And I think we don't need to display the quantity, the bidder for the moment. And right here, we want to do a method call that we can use to accept the bid. Method function. So let's not write something in the file method.ts because this should be a very quick function. I just want to check something. And I think that this function can be so we need to return. We need to have a function that returns a function. And this is a wait. Yeah, client accept bid with asset the buying asset ID and the nonce being 0. And we want to increase the fees because for any accept bid, it could be that there is a previous bid in the contract for that listing. So we want to provide at least the fees to do all the refunding. So send params, this needs to have a fee in microalgos of 3,000 to cover for 2 inner transaction at most. Let's open up the contract and see. Here we are in the contract and we're checking for the accept bid. Wait, I was totally wrong. We refund the previous bidder in the bid method, not in the accept bid. The accept bid will always send 2 transactions. One is the payment to the seller, and the other is the assets to the bidder. Okay. We're missing something from here, which is the text. We can say that this is accept. Let's interpolate this with number. We want to show how much the user needs to spend to bid this much. So the number is best bid query data. So the quantity, as usual, times the price, only corrected for the correcting factor, which in this case, we know how much it is because we are creating the asset and we know that there are 6 decimal places in the algos to microalgos. Okay, so we covered the button and we're displaying the bid and we're also providing the possibility to accept that bid. Now we're only missing the code to place a bid. And I mentioned that we want to use the same form that we used for placing a listing. And so I think let's just create another button here, a method call. close it. And this should be an asynchronous function. Have I, hold on, does this need to be potentially? I'm wondering if this is the quickest way to write this, but let's run with it for the moment and we'll see if we are correct. Okay, so this function needs to be, so let's think about it for a second. We want to place a bid, which means that we need to also need to send algos to the application, right? Because we said that the application is going to hold the algos for any bid. So we need the address of the application first. Get reference. And then we bid. So the owner is going to be the seller address, and the asset is going to be the buying asset. If it is confusing, you can make two separate forms. This is why this is the buying asset ID, even though in this context we are using it to place a bid and not a buy. Nonce is fixed to 0. Now we want to provide a bid pay, and we use the Algorand client to do this. Use the transaction object within the Algorand client, not the send object, because the transaction will just create it. And because we want to group it with the method call, we don't just want to send the payment. Okay. So the sender of this payment is going to be the active address, and the receiver, the app address. The amount, as usual, we use the micro algos, and here we have the buying quantity times the buying price. This time only corrected for the number of asset decimal digits in the asset, because this is in micro algos. If this was in algos, we would need to correct for 1E9. Since we are passing grouping a function with the method call, we are using it to also pass some extra fee, because for the bid, if we take a look at the bid method, this potentially refunds the previous bidder. And then the actual parameters of the new bid, which is the buying quantity and the unitary price. This is the buying. As a text, bid, interpolated with some code. This is the buying quantity times buying price. No, buying price. Now we correct for 1E9 because we want to display algos in the button. So this is algo for buying quantity unit of ASA. Okay. Perhaps we don't need this. Ah, yeah, no, I don't think so. So actually we should be done. So let's open the other terminal and run the web server. I'll set up a scene where you can see the code and the web front end at the same time. So I'm going to briefly pause the recording. So you should be able to see now the web app. This is pretty much still um, how we remember it, and we're going to see some modifications while we start using it. So I think we are connected with our wallet, and let's create the marketplace. Okay, so we have a marketplace with the ID of 1079. Let's create some listing. The amount to sell, I think, should be 1.5 units for a selling price of 3 algos. Okay, 1079. Okay, and we can see our listing for a new asset, 1.5 units for 3 algos each. Okay, we don't have a best bid yet, obviously, because we didn't place one. So, but we have our button to place a bid. So let us copy this address. The asset to buy is 1081. I would like to bid for 0.7 units at a price of 2.5 algos each, right? So if I try to buy, this is going to have result in an error. If I try to bid, this should create a new bid. Okay, let's try to create a bid then. Ah, this is interesting. Let's see what went wrong with there. I'm going to do some debugging and resume the recording. I'm not sure what went wrong actually, because I did it a second time and it worked just fine. So I'm not sure what happened there, but um, yeah, we can see that I just updated the page and the same app ID. No, this doesn't matter. This should be 0. But if we identify a listing with the seller address and the asset to buy, we can see that we have a best bid. We have a bid present. So now we still see the listing as selling 150. I'm sorry, 1.5 units of that asset. So if we accept this bid, we should see everything lower by the relative amount. So let's refresh the page and copy. Oh yeah, I mean, we can already say it, right? Um, but now the asset to buy, this is 1081. Okay, so we can also see that not only we lowered the quantity of the deposit, we also lowered the quantity of the bid. So this will be one of those strange cases where one of the two quantities is 0. But again, this would be an empty trade, essentially. It doesn't create issues for the parties involved. But yeah, I think this concludes this session, and thanks for watching. And I hope you take this project and make it your own. Try to create something new, and maybe this inspired you to develop your own application using the techniques that we've seen in this bootcamp. So thanks again, and goodbye.